Okay, this is I've seen this on IB tests so often. It's like their favorite question. Okay, they don't tell you what the point masses are, but they tell you that when they are 56 centimeters away, there's this force on them, right? And then we want to know what their separation is when there's a larger force. Of course, they're going to be closer together, right? But you don't know what the masses are, and so you're in a bit of a fix, right? But there's got to be a way to do this, and the way to do it is to set up two equations um, with two unknowns. So let me just show you this. So in general, these are masses, so our force of gravity is G m1 m2 over r squared, right? So here they are at some separation, right? And then later on they're at some other closer separation, presumably, right? So this is 56 centimeters or 0.56 meters, right? Actually, it doesn't matter, but there it is, right? Um, and then later on, they're at some other distance x, I'll call it. Okay. So what we do here is we just say, okay, let's see. I'm going to set up two equations. So they are 2.30 times 10 to the minus 12th, and that's g m1 m2 over 0.56. By the way, it doesn't even matter if you don't convert to if you don't convert that to meters. It really doesn't matter. Okay, and then my second equation will be 5.80 times 10 to the minus 12th is equal to g, the same two masses. That's the trick here, right? It's got the numerator of both of these is the same, right? Divided by x squared. Okay. Now, what I can do, here's what I can do, is I can divide these guys. I can divide this left side by the left side and the right side by the right side. And when I do that, I get 2.3 over 5.8 is equal to, and then this is kind of crazy because it's 1 over something and 1 over something like that, right? Okay, ultimately when the dust settles, I'll have x squared over 56. I'll stick with 0.56 squared, right? Okay, and then you're wondering what happened to the times 10 to the minus 12th. I just am lazy, right? You go ahead and put it in there if you want. It doesn't matter though because it cancels out, right? This divided by this will end up being this, right? And then I could have left this 56 and then I get an answer just like that, but I didn't, so I'm not gonna. All right, so let's see. So how do we solve that for x? I guess cross multiply, right? So 2.3 over 5.8 times 0.56, right? That's x squared. And then if I take the square root of this, right? If I take the square root of both sides, I ought to be good, right? So I'm going to go square root of parentheses 2.3 divided by 5.8, right parentheses, times 0.56, the square root of that. The square root of 0.56 squared is just 0.56, so I'm just going to go times 0.56. And I get 0.3526. Meters, which is 35.3 centimeters. Okay, so what you do is you just set up the two equations, fill in what you know. Sometimes you don't know the force, sometimes you don't know the r. That's all there is for these types of problems, right? Set them up, and then don't forget that when you divide this side by this side, right? Of course, the numerators cancel because they're the same, and then you end up with a crazy thing, but it ends up being like this, right? The x squared ends up triumphant on the top, and this guy is in the denominator. And then you can just solve that. Okay. Happy hunting.